Hey everyone, this is question 90 from chapter 6. All right, so this problem is about a ball attached to a string being let go, and we're asked to find the speed at the bottom of this speed at the bottom of the swing of the ball on the string, and then if there's a peg attached at H, what the speed's going to be at 3 here, okay? So we can start by doing, we need speed at 2. That's just going to be an easy conservation of energy. E1 equals E2. The ball's being released from rest, so we don't have any kinetic on the left side, but we have mg. H here is just going to be the full length of L, because we're setting this point down here at 2 to be our origin, all right? So mgl equals, when it reaches the bottom of the swing, we don't have any potential energy because we set this equal to 0, so it's all going to be kinetic, 1/2 m v2 squared. All right, so rearrange that, and we get v2 equals the square root of 2gl. Pretty basic. All right, and that's part A. Okay, so then part B asks us to find the speed at point 3 here with the ball swinging around this peg, okay? So let's figure out the potential energy here first, because we're going to have to find this distance, and right now we don't know what it is, all right? So we're going to start with y3 is equal to 2 times L minus H, okay? And that's because we're including this portion down here. Use a different color. We're including this portion down here and this top portion, so we have to do it 2 times. Okay, so y equals 2L minus H. Plug in the numbers that we have. Y3 equals 2L. We're told that H is 0.HL. All right, and if we distribute 2 to point of L, we get that y3 equals 0.4L. Okay, so now we can go on and do conservation of energy between points 2 and 3 now that we have that length. Okay, so E2 equals E3. I already said there's going to be no potential energy down at the bottom of 2, so then we're just going to have 1/2 m, and our velocity v2, we just solved for v2, but in this case it's normally 1/2 mv squared, but the v2 just equaled the square root of 2gl. So we can square both sides and get a term for v squared. It's just going to be 2gl. Okay, so that's kinetic for 2, and then we're going to have kinetic energy at 3, 1/2 mv3 squared, which is what we're actually solving for. And we're going to have that potential energy we just solved for L, so it's going to be, or we just solved for H, it's going to be mg 0.4L. All right? And then we rearrange that and solve. For V3, you get V3 equals square root 1.2gl.